Okay, the end of the unit review. I'm not going to go through all these questions. I'm just going to go through a couple. So for this one, identify all the asymptotes. So there's going to be two different types of asymptotes, right? There's a horizontal, which we'll call HA, and a vertical asymptote, which we'll call VA. So every equation is either going to have, every rational expression will have two of them. Okay, so the vertical asymptote is the easy one. We just go through and look at what makes the bottom 0. So this one, for example, x minus 2, if I plugged in a positive 2 for x right here, that would make it the bottom 0. So my vertical asymptote for this one is a positive 2, because if I plug in the 2 here, the bottom becomes 0. The more difficult one is the horizontal asymptote. Okay, so when you're looking at a horizontal asymptote, you look at the degrees of the top and the degree of the bottom. Remember that the degree is the highest exponent. So we have a 2 on the top and a 1 on the bottom. And if you look at your notes, if the degree on the top is larger than the degree on the bottom, the horizontal asymptote does not exist. So we'll call that D and E. So I'm going to skip to one that's a little bit more challenging. If we look at F, my vertical asymptote, we're trying to see what makes the bottom 0. Well, for this one, it's not as easy to see as for letter A. So what you could do is set 4x minus 1 equal to 0, and then solve for x. And you'll see that x is equal to 1/4, which means our vertical asymptote is 1/4. All right, so remember the vertical asymptote is whatever makes the bottom 0. If you can't see it easily, set the bottom equal to 0 and solve for x. The horizontal asymptote, we're looking at the exponents, more specifically the degree. So the top has a degree of 1 because this exponent is 1. Same thing down here, 1. So because they have the same, you want to divide the coefficients of these two. So we have 2 divided by 4, which reduces down to 1/2 or 0.5, whatever you choose to do. So your horizontal asymptote is 1/2, and your vertical asymptote is 1/4. And it's going to be like that for the rest of them. Make sure that you're reading the question, because we're not dividing these, we're just identifying the asymptotes. All right, for number 2, we're matching the function with its graph. So remember that an asymptote is like these dashed lines that the graph gets really close to but doesn't actually touch. Okay, so one of the things you could do is just start with the vertical asymptote, which is the bottom. So set the bottom equal to 0 and solve and see where that line's at. So our vertical asymptote for this one is going to be a positive 1/2. And I did this just by mentally setting this equal to 0 and solving. So now I'm going to look for a positive 1/2 with a dashed line. So that would be no. This one is close, but that's right on the 1. If you look at letter D, this dashed line is in between 0 and 1, so that's going to be 1/2. So the first rational expression goes with graph D. For number 2, our vertical asymptote on the bottom is going to be a positive 1. So I'm going to look for a positive 1, which I just saw earlier, and that was right here, so for C. So letter C is your go-to. The vertical asymptote for number 3 is negative 1. So if you look at the graph, we have a negative 1 right here. There's that dashed line at negative 1. So B goes with 3, and the only one that's left is A. For number 3, I'm only going to do one of them because I only have enough space for one of them. I'm going to tell you right now not to worry about this one and this one all that much. If you did it, great, but don't worry about it too much. We're going to look specifically at this one. So we have x plus 3 divided by 2x squared minus 7x minus 4. Okay, so you want to start with the leading terms of each. X, how do I get from x to 2x squared? I multiply by 2x. So I line that up in the x column. And then I take that 2x and multiply it by everything in here. So 2x times x is 2x squared. 2x times 3 is a 6x. And these are both positive, so I got to come through and subtract them. That leaves me with a negative 13x minus 4, because I bring the next term down. Now I'm looking from x to negative 13x. How do I get from x to negative 13x? Negative 13. and then I take that negative 13 and multiply by each of these. So negative 13x and negative 39. And then these are both negative, so I have to go through and change the sign to add them. That leaves me with 35 right here, and that's a remainder. So how you write this is 2x minus 13 plus 35 over what we divided by, x plus 3. So whenever you have a remainder, it goes over what you divided by. And that makes sense, because if we did 7 divided by 24, 24 divided by 7 would be 3, right? And then we'd subtract the 21 and have a remainder of 3. And this would be written as 3 and 3/7, because we had a remainder of 3 divided by 7. We're going to do the same thing over here. So whatever your remainder is, put it over what you divided by. For number 5, for polynomial identities, we're trying to see if what's multiplying actually equals this. And if it does, then it's an identity. So I'll start by drawing our box. 3x minus 2y, 2y minus 3x, and then we fill in the box. So 6xy. Because these have different variables in x and y, we can just write them together. Instead of writing like x squared, because we don't have 2 x's, you just write them as 2 times 3, which is 6, and then x times y, which is just xy. This becomes negative 4y squared. This becomes a negative 9x squared, and this becomes a positive 6xy. And you want to combine those terms. So you're left with a 12xy minus 4y squared minus 9x squared. And you can see clearly that this is not equal to this, so no, not an identity. All right, moving on to the next one. We have this word problem. So they give us this rational expression, 800 n of p equals 800 over p. So what does n of 150 mean? So that would be the 150 shirts, or if I spend 150 shirts. So this expression, this is how much money you spend on the shirts, or how much shirts you buy, and this is the cost per t-shirt. So read that the number of t-shirts they can buy is a function of the price of the t-shirt. So price per t-shirt. So this is 150 shirts. N of 150 is the price per shirt for 150 shirts. All right, so the bottom right here, this is the number of shirts that we're purchasing. And then the top is how much each shirt costs based off that number. So then if I did some quick math, I have $800 to spend divided by 150 t-shirts. It's going to be $5.33 a shirt. That's what this would be. So it represents the price per t-shirt. Where's the vertical asymptote, and what does it mean for this situation? So the vertical asymptote right here, it doesn't look like it, but it's actually going to approach 0. But it's never actually going to touch it. And what that means is, so we have this right here, like you can't not buy any shirts, right? So the fewer shirts you buy, though, so less shirts total, so the less shirts that you buy total, so the farther we're here, so you buy 20 shirts or 10 shirts or 5 shirts, the more expensive per shirt. All right, so think if it was $800 to spend and I bought 4 shirts, I could spend $200 a shirt, right? But if I had $800 and bought 200 shirts, I can only spend $4 a shirt. So you can see that as we're increasing, the value gets smaller and smaller, and that's the horizontal asymptote. So the horizontal asymptote is going to be 0, which means the more shirts we buy, more total shirts, less expensive per shirt. All right, and for number 7, I'm gonna do this first one right here. So what we're gonna do for all of these, you're going to cross multiply. So 3 times x is 3x, x minus 2 times x minus 4. I'll write it like this. And you're going to want to box those, okay? So real quick, I'll do my box because we're multiplying them. So we get x squared, negative 2x, negative 4x, and positive 8. All right, so 3 times x gave us 3x. X minus 2 times x minus 4 I rewrote as this, and then I boxed it. And so that gives me 3x equals x squared minus 6x plus 8, because this negative 4 and negative 2 gives me negative 6. So then what I have to do, because I'm trying to solve, they said at the very top that we're solving. So I need to bring this 3x over to combine it with this. To do that, I have to change the sign. So it was positive, then it's going to be a negative over here. So we have 0 equals x squared minus 9x plus 8. The reason it's 9x is because negative 6x and a negative 3x gives me a negative 9x. From here to solve, you want to get, you need to factor. What factoring means is take your number 8, all the numbers that multiply to 8, and we're going to see which one of these pairs of numbers that multiply to a positive 8 combine to a negative 9. Okay, so these all multiply to a positive 8. The ones that we choose, though, have to combine to a negative 9. So that's going to be negative 1 and negative 8. And what that means is that we have 0 is equal to x minus 1, x minus 8. But remember, this is factored form. This is not your solution. Okay, so when we talked about this factored form, if I say factor, this is what I want. If I want you to solve, or the solutions, you just take the opposite of it. So x actually equals 1 and 8. Those are your solutions. And the reason we want our solutions is because they told us to solve.